Hi TAs and instructor, this is a demo video for the Jupyter notebook of our final project. The goal is to build an AI that plays Google Dino game by using reinforcement learning, specifically DeepQ network with convolutional neural network policy. The code needs to be run in a very specific coding environment, so if you don't want to go through all the package installation, you can just watch this video. But all the packages that needed for this project are provided here as a pip install command. So if you want to try it yourself, go ahead. Once we have our training environment, now it's the time to build the game environment for the AI to learn how to play the Google Dino game. The detail of how we implement this is provided in our final report. So once we have the game environment, we can test the function inside the game environment, see if it's working. So we put this to a side. First, we need to test out the observation window, see if it captures the Google's Dino and the cactus. So this is our game space. So second observation window we are going to check is the observation window that captures game over. It tells the model when the game is end. So we do the capture, and boom, you see it captures the game over and returns a boolean object if the game is over. So this for loop triggers the environment to start and how many games your AI want to play. After that, it's time to create a callback information. This is not as important, it's just to finalize the directory of where your logs want to be, so that at last we can provide a visualization for our training logs. So once we have that, we can finally build our DQ network model. We borrow the model from the stable baseline 3, and inside our final report we also provide how we finalize these hyperparameters. Now everything are settled, we can train the model, but we will skip this part because it takes so long, approximately 10 hours to do. What we are gonna do is to load some pre-trained models I trained several weeks ago. First, we are going to load a under-trained model. This one only get trained for an hour, and we are expecting a pretty poor performance. Oh, sorry. So we are going to load this one and use the for loop to trigger a start to play it 3 times to see how the AI performs. As you can see, the AI still don't know what to do. You just randomly sample actions from the action map and just keep collapsing on the cactus. Next, for comparison, what we're gonna do is to load a wheel performance model. This one trained about 6 hours, and same using the for loop to trigger its start. As you can see, now the AI knows what to do. The AI knows when it sees the cactus, it jumps, and when they see the birds, it will duck. So we definitely can ensure that the AI is like having their own understanding of this game. Probably I'm out of luck this time. We only get 201. It's also a pretty remarkable score for a very easy reinforcement learning model, but the highest score we get, the floor, is about 390. So after the demo of the results, if you are if we are interested in the model over time, how does it train, we can borrow the TensorBoard to visualize our report. I mean training logs, and you can find a very detailed interpretation in our final report as well. Thank you.